Okay, so this video is optional, but these are a couple of problems that will be on your assignment, so you may want to pay attention to it. If we look at this polynomial right here, this polynomial has 4 terms, which means it might be factorable by grouping. And if it is factorable by grouping, we want that. Remember, factoring is the king for this stuff. If it's factorable, we don't have to do Descartes rule of science. We don't have to do synthetic division. We don't have to do the rational zeros theorem. So if you have been looking at this, then you should certainly see that this is absolutely factorable. So remember, I get to take an x squared out of this first set right here. That's going to leave 2x. And then that's going to be minus 1. And then, of course, that is a 2x minus 1, but you always have to factor out something. So I'm going to write plus 1. So our factored polynomial is x squared plus 1, and then 2x minus 1. So if I want the real zeros, well, we only have one real zero. The one real zero is going to be this. If I solve for x right here, I would get a positive 1/2. If I solve for x for the other zero, if I solve for x for this other factor, y'all, it would be imaginary. So the imaginary zeros are just i's. Remember, I have a degree of 3. I have 3 answers here. Feeling pretty confident about my work. I'm going to go ahead and box that in. Let's take a look at another one. All right, so 1, 2, 3, 4, 5. 5 terms, can't do factoring by grouping, so I'm going to have to go through the process to find the zeros for this. Remember, the first thing I need to look at is Descartes' rule of signs. Descartes' rule of signs. So if I analyze the positive, here's where it flips to negative. That's one change. Negative and then positive. So it has 2 changes here. So my positive possibilities are going to be 2 or none at all. Now let's analyze the negative change. Okay, so this is negative, flips to positive, that's one change. This is positive, flips to negative, that's one change. Stays negative, turns back to positive, and then there's no more changes. So my negatives are either 2 or none. So now that I kind of know what's going on with the nature of the roots, let's find all possible roots. And remember, that's going to be p over q. P is the constant, Q is the leading coefficient. So P is a 2, so the possible factors that make 2 are just 1 and 2. Positive and negative. And our leading coefficient's 1, so that's just positive or negative 1. So our possibilities are going to be 1 divided by 1, 1 divided by, or that's my bracket, my brace, and that's it. 2 divided by 1, and then that's what we've got here. Okay, so remember, they can be positive or negative. So the first thing I'm going to do is I'm going to start doing synthetic division. So here we go. We are moving on to the next step, which is going to be synthetic division. And I'm just going to try a positive 1. So all of my degrees are represented, so I'm not going to have any zeros. So 1, that's going to be a 1, 1, negative 3, negative 1, and a positive 2. All right, so let's synthetically divide. And thank goodness there is not a remainder on that. And remember, when there is not a remainder on that, x-intercept, one of the x-intercepts equals 1. And remember, x minus 1 is a factor, and that makes us happy. Okay, let's take a look at the depressed polynomial, the quotient, what's left over. So remember, that was a degree of 4, so now that's going to be x to the third plus 2x squared minus x minus 2. So now that we have this depressed polynomial, let's analyze it. Are there an even amount of terms? Yes. Could we factor by grouping? I don't know. Let's find out. So for these two, I can take out an x squared, and that's going to leave x plus 2. And here, when I factor out a -1, they're going to match. So I'm going to factor out a -1, and that turns into x plus 2, which is great. That means we factored it. So let's go ahead and write this in factored form, which is not yet because I have a difference of squares right here. So it's going to be x minus 1, x plus 1, x plus 2. And then don't forget to grab your factor that you found up here. The factor that I found up here is x minus 1. And I already have an x minus 1. So I'm going to use my exponents because x minus 1 happens twice. So this polynomial in factored form looks like that. And from here I can find all of the x-intercepts. So the x-intercepts are going to be a +1. It's just going to be tangent on the x-axis, a -1, and a -2. And that's going to be the answer for that problem. Just want to kind of zoom out so you can see the whole thing. And of course, I like to box in my answers. Remember, factoring is keying on this. If you can factor, if you can identify when you can factor, it's going to save you a ton of time on this.